In this video, we'll go over some examples of ionic compounds. Let's start with how to write the ionic formula of an ionic compound. This is some of the information we're going to need to do this. Let's look at the trends for ionic charge on the periodic table. We know that this correlates to the valence electrons in each element. So our group 1 elements all have a charge of +1. Our group 2 elements have a charge of +2. We're going to skip over the transition metals, and here we've got this group has a charge of +3, this group has a charge of -3, -2, -1, and the noble gases have a charge of 0. This group here can have a +4 charge or a -4 charge, depending on what it's paired with, so I didn't include that for now. The transition metals don't always have the same charge. The charge will be indicated by Roman numerals, and we can see that in some of our examples, so we need to keep that in mind. Finally, we need to know some of the common polyatomic ions. These are ions that are made up of more than one type of atom, bound together, and they have an overall charge. These are just something that you'll need to remember over time. So let's do some examples now. We'll start with aluminium chloride. So I'm going to write down the symbol and charge for an aluminium ion, and I can see, looking at the periodic table, that aluminium will have a charge of +3. And then a chloride ion is going to have a charge of -1. What we're going to do is we're actually going to bring this value down and sit it next to chloride, and this value and sit it next to aluminium. So Al with, this is a 1 charge, so I'm going to put a 1 next to it. And then chloride, Cl, I'm going to bring this 3 and sit it next to the Cl. Now we don't actually write the value 1, so my final answer here will be AlCl3. Lithium oxide. Lithium is in group 1, so it's going to have a charge of +1. And oxide will have a charge of -2. Same thing, I'm going to bring the values down and sit it next to the opposite ion. So lithium, I'm going to bring this 2 down and sit it next to lithium. And then oxide, this 1 will sit next to the oxide ion, but we won't write the 1, so this is our final answer. Here we have a transition metal. So iron has a symbol Fe, and the charge is indicated by these Roman numerals. So this one has a charge of +4. Oxygen, again, oxide ion has a charge of 2-, and we're going to bring these values down and sit it next to the opposite ion. So here I've got iron with a 2 next to it, and then oxide with a 4 next to it. Now, this is not the most simplified version of this ionic compound, because here we've got a common factor that goes into both of these numbers. So I'm going to simplify it the same way I would simplify a fraction. Fe, 2 goes into 2 once, so this will become a 1, which we don't write. 2 goes into 4 twice, so this is going to be O2. Magnesium sulfate. Sulfate is one of our polyatomic ions, so it's this one here, which is what we're going to use. So magnesium has a charge of 2+. Sulfate looks like this, SO4, and it has a charge of 2-. So same thing, we're going to bring the value of the charge and sit it next to the opposite ion. So I'm going to have Mg 2 from here, and then SO4 2 from here. Now I can't just sit the 2 next to the 4 like this, because this 2 applies to the entire polyatomic ion. So I actually need to include some brackets to make sure that this 2 goes to everything in the brackets. Similar to this example, we can simplify this. We can actually just cancel the 2's out. So we're going to have Mg SO4. And I don't need the brackets anymore because I don't have a number out here. And now we have nickel 2 hydroxide. So nickel is another transition metal, and it's going to have a charge of 2 plus. Hydroxide is another one of our polyatomic ions, and it's going to have a charge of -1. So same thing, going to bring these charges down, the value of the charge. Next to nickel, it's going to be a 1, which we don't write. And then next to hydroxide, we're going to bring down this 2, which means I need to include some brackets so that this 2 goes to everything inside that ion. Now let's look at naming ionic compounds. I've got all the same information up the top here. When we name ionic compounds, the cation, which we've got first, will just have the same name as the element. So Na is the element sodium. But our anion, we replace the end of the element's name with "ide." So instead of writing chlorine, I'm going to write chloride. Same thing here, we've got Li, which stands for lithium. And then O is the element oxygen, but it's an anion, so I'm going to write oxide. Here we've got a polyatomic ion, so we're going to write sodium first as our cation, and then the anion here is sulfate. So that's this one here. Here we have a transition metal, so this means we need to indicate the charge using Roman numerals. So if we were to write this formula from the name, we would have some unknown charge for iron and a -1 charge for chlorine, and we would bring the value down and sit it next to the opposite ion. So here we've got a 1 next to iron, which we don't write, and then next to chlorine, or the chloride ion, we're going to write the charge from this one. And we can see that that's a 2. So that means that this one has a charge of +2. So when we write it, we're going to say iron 2 chloride. Same thing here. So we've got nickel and we have hydroxide ion, and this -1 will come down next to nickel. Some charge will come down next to hydroxide, and we can see that that's a 3. That means this nickel has a charge of +3. So we're going to write nickel 3 hydroxide.